Yes, yes. Hello.
Can I take square root 1 plus
It's
log?
not a square root, but I understand what
Root,
you mean. But,
yeah,
but let me write the original problem. So you remember we had an original problem. Ismail told us to do something. We came up to here. I said we couldn't continue because we didn't have time. Then I asked you think about it. Even here it's a good problem. But the original problem was logarithm of x to the base 3 plus what was that? Logarithm of x to the base 5 is equal to logarithm of 225 to the base 3. That was the original problem. So Ismail actually told us something, so we followed him. And the reason I was interested to follow, even though might be this is not the best way, is because I use this as an excuse to ask you a lot of questions to pick up your curiosity level. So we came up to here. Okay? So then I told you that forget about the original problem. This problem itself is also an interesting problem. So we want to solve this problem now. So the question is that what x is. In principle, if you want to compare this with what you can compare it, if I give you x to power 2 is equal to 225, you can solve it, yes? So what's the answer? X is plus or minus the square root of this. If I give you x to power 3 is equal to 225, hopefully still you can solve it. You can say the third root. If I make it x to power 5, you can still solve it, hopefully. This is math 1c. You can write it the fifth root. But let me say what happens if I have this root. Can you still solve it? If I ask you what is x, so this is a harder question. This is at the level of math 1c. I don't know how much you remember, but before doing this harder one, let me ask you a question to refresh your memory. If I ask you to solve this, this is even, you write plus or minus the square root of 225. If I ask you what is this one, because this is odd, you don't need to put plus or minus. You write the third root of 225. This one you write the fifth root of 225. So more or less you understand what to do with an integer power here. But what happens if I have a fraction there?
You put it, but you turn them around.
Yes, why? Because in principle, what you are doing, you are raising both sides by the reciprocal of that number, whatever that number is. Why reciprocal is good? Because if I have an exponent and I want to exponentiate it once more, the rule is to multiply these. What happens then? 3 times 2 is 6, 2 times 3 is 6, 6 over 6 is 1, x to power 1 is just x. And that is your answer. You might be pleased with its answer, or you might not like it, so you can calculate and simplify it. But that is your answer. You are looking for x as a number, you found it. The number is a little bit weird, but that's a number. So the same strategy should work here, yes? So we don't need to change the strategy. I hope that you understand with me. This problem is comparable to all of these problems. Not with these very simple ones, because for the very simple ones we have extra sign, we can use that symbol. But you can compare it with this one. So that is what you want to say. So probably, now can you tell me what should I do? If I write this, 225. First of all, can you tell me, can I write this as 1 log?
Yes.
How?
You can log 5 to the base.
Exactly. So instead of 1, you write log 5 to the base 5, and then what do you have? You have log of 3 to the base 5, yes? Yes? And then you can write it as what? Log with 5, but what is the number? 15, because addition is changed to multiplication. So instead of having that, I can write x to power log of what? 15, 5. Yes? And this is equal to 225. Agreed? And now what?
Move
I cannot say I finished the problem because I have not isolated x yet. I want to get rid of this. So you see, let me review these things. That's not bad. So if you have a plus x equals to b, if you want to isolate x, what do? You move a. Yes. If you have a times x, if you want to isolate x, what do? You divide. Yes. And if you have a power, you want to isolate x, what do? You raise to power 1 over a. So x becomes what? B to power 1 over a. So these are at the level of your knowledge. You need to have it handy in your head.
Absolutely.
If I have addition to isolate, I move. If I have multiplication I want to isolate, I divide. If I have an exponent I want to isolate, I raise to 1 over that power. Why? Let me review again. X to power a is b. X to power a to power 1 over a becomes b to power 1 over a. But a times 1 over a is x. It's isolated now. Okay? So you need to remember these techniques. And now I want to isolate x. This problem is not comparable to this, is not comparable to this, but it is comparable to this. So I have to use the same trick. So what can I write? X is equal to 225 to which power?
To the power of 1.
1 over that number, whatever that number is. And then you are happy. This is your number. It is correct. But if you can make it more beautiful or more friendly, that's also part of the game. It's better to do it because, first of all, it is fun. So, secondly, this is a very weird number. If you go to a shop and say, I want this many pocket of milks, that poor guy will be confused. Yes. Okay. So you need to make it more concrete to the people. But do you remember? I mean, if you do it, if there is 4 points for this question, up to here you get 3.5, or probably 3 points. So it means that it's very good. And by the way, this is exceptional. It is most of the time in practical situations, we cannot do it very friendly. This is why we have to use calculators at the very end. But this is one of those cases, if you are smart enough and you have a lot of things in your memories and then can connect them very good, you can immediately do that for me. So let me ask. Yeah, Shah, told that the first. Yes, we learned something about this yesterday. Do you remember? 1 over log of a, b can be written as log, but then ba. Yes? Do you remember if someone asks you, this is something that you have it in your memory, but let us say you go to another school or a friend comes from another school and asks why this rule is correct. Can you tell me why? Why this rule is correct? Do you remember why was this rule correct?
Because log b divided by log a is log.
Exactly. So we had the change of basis formula. But if you ask me why that change of basis formula is correct, I proved it for you, yes? So we had this formula, and if I ask you what happens if I have b up there and a below, then it becomes very similar by changing b and a. But then if I ask you how these two numbers are related, you immediately see that they are reciprocal of one another. Okay. So if I want, I can continue further in this case. Instead of this, what can I write? 5 here, 15 here. Yes.
Now you can factor x 225.
Ah, yes. So that is the number. So for me, it was simple to understand because I have this number in my memory. If you don't have that number in your memory, so yeah, you have to find a way to do it, of course. You can factorize 225 or whatever, but 225 might be, if this is an exam question, I give you this hint. So it is 15 to power 2. But now that it is 15 to power 2, can I continue further? So it becomes 15 to power 2, and then to power log of 515. Do you remember I told you something? that if you want, you can replace these two exponents, yes? A to power x to power y is a to power xy. A to power y to power x is also a to power yx. These two numbers are equal. So whenever you need, feel free, you can change it. So we need it here. Why? Yes? So it becomes this one to power 2. But what is this number?
55.
No, this is 5. And then I have a power of 2 there. So finally I have 25. So that number that fits to this equation is 25. So and the reason I told this one, I'm not telling you that I will give you this in the exam. So exam will be at the level of the book. Okay? But the problem is that for solving this, you are learning a lot of things. You will not learn until you really engage with the problem. Okay, but even if we did it in that way, hopefully you'll learn. If you have forgotten, you can review the video. But the problem is, can I do it a little bit differently now? I mean, did you think about it? Find another way. You can think until I can change this refill. So let us go back to the original problem, and I want to hear from you, okay? Don't give up. So you see, Ismail is absent today, but he gave this idea, and it worked finally after a very long time. So the answer is 25. And it was not easy to guess, to be honest. I couldn't guess that the number that fits. By the way, I forgot to say something. What was that? A logarithmic equation might have a false root, but that's not a false root, yes? Because it doesn't make any problems here, it doesn't make any problems there, yes? That's an acceptable solution. Okay, let us go back to the original problem. Let us see what other things you might think. Any ideas?
Well, you can move log x over 3 to the other side.
It is not bad, you know. By the way, learn this. This is a good idea. Even I think as you did, and I don't need to read everything until the very end. This is why you have a scratch paper. Okay, scratch paper means try your ideas to see if it works or not. So this idea is good. Why didn't you tell me move this one? You decided to move this one. There is a reason. So you see, I am telling you to do trial and error, but I don't mean to write every nonsense that you can come up with. Yes? Because you're wasting your time. So why did you choose between these two to move this one, not that one?
Because
Yes, because you see this is a 3 and that's a 3, then I have a formula. But if I move this one to the other side, then what? I have wasted my time. Yes? So what I do, I keep it. And I don't know, even might be you don't know if it is going to work or not. But that is an idea. We have to discover if it works or not. So what we do, we write the logarithm of 225(3) minus logarithm x to the base 3. And you don't need to stop here because you move this for a reason. And then don't think, do it. So copy and paste this part. And then, what should I do here?
log 225 divided.
Yes, that is the famous formula. But then immediately you see a problem happens. Now, can I just drop the logs here? Unfortunately not. Because one log is with base 5 and the other log is with base 3. So unfortunately, I cannot drop. Either I have to give up at this point, or be creative, find another way to continue. At least you shouldn't give up hope, you know.
You can do Ismail's method.
What?
You can do Ismail's method to have the same base on both sides.
So can you explain more?
You can do on that side 3 to the power of log 5 over
Yes.
3. And then you can put the exponent at the start and put 1 over it. Then you can take that and put it over the x.
Okay, let us do it case by case. So what you are saying is that let me write and ask others, because he has a good idea. Let us see if it works. But I want to tell me why this is true. He's saying, if I understood him correctly, he said write 3 to the power of logarithm of x to the base 5.
No.
And then it becomes equal to 225x. Is that what you mean? First of all,
Yeah.
I might be this is not what you mean, but is it legal, mathematically valid to write this? Yes or no?
Yes. Yeah. Isn't it?
Yes. Because you see, if I write logarithm of a box to the base 3 is equal to a circle, and if I ask you what is the connection between, what is the relation between the box and the circle? This is a matter of seconds. If you are solving at this level, you should answer this in milliseconds.
Equal.
Come on. So how is that possible? I don't understand. So I cannot feel what you say, because you are saying something very advanced on the one hand, and then you get going, no, this is not zero. This is not zero. This is circle. You consider this. No, I'm asking you. This is a box. This is a circle. I don't know what is here. I don't know what is here. But what is the connection between box and circle now?
3 to the power of.
3 to the power of circle is the box.
Yes.
So here, this is playing the role of circle. This is playing the role of box. You see, this role of this box and circle idea, it is not hard to learn, but when you learn it, you can use it a lot of times. So do you agree? So you told me 3 to the circle is box. Yes? And that's exactly the same thing. This is my circle. This is my box. So 3 to the circle is my box. I'm not saying this is good or bad, but I'm saying it is correct. And I want you to understand this is correct. Yes or no? Okay. But is it correct and useful or correct and useless? Because that is the whole point. It might be true and useful. It might be true and useless. I don't find any idea solving the problem. Can you?
I think you misunderstood what I meant.
Okay. But this one is true,
Yes.
but apparently useless. Because I have one unknown top there, another unknown in the bottom of the hell. No? Up there in the heavens and the hell, yeah? So up and down. Okay, so what can I do? So let us forget about this, or at least I couldn't find any way to continue. It was correct, but useless. So I do it in a scratch paper, get used to it. If you want to be a good mathematical problem solver, you have to get used to it. Okay, so even though this is true, I drop it, the idea. Okay, so now what did you say?
I meant you can replace the 5 on the left side with 3 to the power of log 5 over 3.
Okay, can you tell me and I copy what you say. So what should I write?
Log.
Read it. Log
X
x
3 to the power of base 3 to the power of log 5 over 3. 3
3.
to the power of
The same thing that Ismail said.
the Ismail's idea.
Yes.
Basically.
Okay. So that will give more or less the same thing. Okay. Yes. So if you want to do it, because that is the same equation, so definitely if you use the same idea, it will give us more or less the same thing. Okay. So let us not do that anymore because we use that idea. Any other ideas?
I mean, Baba, is it possible to factorize x or no?
No, well, because x is so simple. How can I factorize it? Until unless I write this and that. Yes. After glue them, it becomes x. If you mean this, yes. Okay. So what can I do? Should I give up on this idea? Because if this idea is good, then the consequence of that idea is here, and one possibility is that one, the other possibility is, I don't know, 5 to that one. Okay, apparently it doesn't work that much. Yes.
Is it useful if we like rewrite some of the stuff to like log x divided by log 5, since then everything has the same
Yes. That is another idea which I was thinking in that way. Yes? So, you see, I followed you. It was reasonably good, but we get stuck, and I want you to get used to it. This is the way that mathematics work. Yeah? Mathematics works. So here, it was correct but useless, but now let me follow your idea, because still we want to have the same base. So what he said is that instead of log of x to the base 3, what can I write? I can write log x divided by log of 3. Everyone agrees? Yes? Can I do that?
Yes.
Yes. What can I do for the next one?
Same thing.
Log of x over log of 5. Yes? Do I need to do something with log of 225 base 3? Not yet. Because log 225 base 3 is unknown or known?
No.
Is known. It is a bad number, I agree, but this is not something I don't know, because if I have my calculator, I put it there, I have it. But this one is known or unknown? Unknown, because I don't know x. Even if I have the best calculator available, I cannot calculate this. So this is unknown. This is unknown. This is known. Yes? So when something is known, don't attack it immediately, because this is something known. Why should I bother with it? Yeah? So I keep it like that. So it's a very bad form of fire. Okay, now give energy to it, like magicians. So what do you think I will do now? Again, I want you to learn this skill. Okay? Okay. If I give you this, do you think you can solve the problem? Do you think you can solve this problem for me? Yes or no?
Yes.
Okay. How do you do that?
Multiply by 15.
Multiply by 15. That is what I want you to learn. Why do you answer this more or less immediately, but you cannot answer that immediately? This is the only way that I can teach you mathematics, by drawing your attention to think. It didn't take even 1 second for you to tell me to multiply by 15, but for some reason, when you see this, it seems horrible, which is not. That is exactly the same spirit, So you have to get rid of fractions. So what do? Is log 3 comparable to 3 in the world of mathematics? Yes, 3 is a number, a known number. Logarithm of 3 is also a known number. But this is this is somehow not a very good number. It's a number, yes? I want you to think in this way. Because if you think, then you can solve a lot of problems that you think is hard. It is not hard. Okay? So you multiply by what? Log of, be ready. Again, I will ask you a question. Don't fall into the same trap over and over again. You should come up, from this trap. Okay, so what we do? I multiply, as you said, by log 3. What? Log 5. But then you have to trust yourself. Now you are in a good level of math. So you do it in your head. Multiply this. You have to multiply this here, here, and here. So you multiply it here. Can you do it in your head?
Log 5.
Yes, because log 3 will cancel that log 3. What is left? Log 5. Is log 5 something mysterious? No, it's a number. So you multiply it there. So it's log 5 multiplied log x. Next one, can you help me? What is the next one?
Log x multiplied.
Log, this one is also supposed to be multiplied here, but this log 5 and that log 5 are cancelled. Log 3 is left, so multiply it here, so it becomes what?
Log x multiplied by log.
Yes. And then on the right hand side it becomes a mess, I agree, but who cares? It's a mess of known numbers, not unknown numbers. So it becomes log 3 multiplied by log 5 multiplied by log 225 base 3. So you don't, if you are a good mathematician, you don't even think about this mess. The only problem that poses for you is to be lazy and write it down over and over again without thinking. So this is what at the end in the world of mathematics it is called it's called a number. We finished. It's a number. It's a number. Okay, it's a number. Written in a fancy, mysterious form as a number. Yes? Okay, but now, and I'm sure that you fall into this trap again. What should I do now? I don't know. Say something loudly and clear, and feel responsibility for what you say. Yes.
You can make log 5 to the times log.
Yes, we can. But is it useful?
Yeah, no, hold on. I wasn't done yet. You can make it log and then square. Or no, brackets 5 plus x.
No, you can do it like this. So first of all, this is good to understand. So for example, you are the teacher now. I am asking you, do you think this can be written in this form?
No.
If you have a good understanding, I am claiming I have a good understanding of logs. So when you ask, I immediately understand, is it positive or negative, the answer. So is it possible to write this like this?
Yes.
Yes. Because again, what is this in the world of mathematics? A number. A number here can go up there. And it has gone up there now. So it is possible. But is it useful? It becomes the same story again. What can I write for this one? Plus, I can write log of what? X to the power of log of 3. Okay, now you want to do this. You want to play this game with me. Okay, let us continue. What else you can do now? What else you can do? You see, what can you do here? Everyone, in a matter of seconds, what is the answer to this? Everyone. Log?
Square and
Log? No, this one. What can I write for this?
log,
Log?
square and circle.
Yes, square and circle. Yes? So this is again, you can answer this immediately, you cannot answer that immediately. This I don't understand. What is playing the role of box here? This. What is the playing of role of circle? This. Yes? So we can do that. So let me write this. If I write this, are you happy? Yes?
Very happy.
So this one, I use that one. So you see, the idea of circle and box is a good idea. I'm using it over and again. And then you are falling to this trap. So I have a lot of fun by putting you in the trap over and over again. Okay, what can I do here now? What can I do here now? So again, this is a surprise for me. I didn't think it's going in that way. I followed you, so it's working. So what can I write here? Yes?
Can you write it as log x to the power of log 5 plus
Yes.
log 3?
You see, I don't know, you don't become friend with mathematics, you know. What can you write for this? What can you write for this? You know why? You know why you cannot solve? Because I told you in the very beginning when I saw you, I told you that behind the formula is a message. You need to know the message. The message is telling you if I have two powers with the same base and I want to multiply them, I write the same base and I add the exponents. If I know this English message, Swedish message, any language message behind the math formulas, then you are not in trouble. Here I am multiplying two powers. The bases are the same, so I write the same base, I add the exponents. So what happens? I can write this as this. Yes or no? Okay. But there is another one for this one. What can I write for that? It appeared. I couldn't anticipate this is coming. This is coming now.
Log 15.
Log 15. Is everyone okay with that? Log 5 plus log 3 is log 15. So it becomes what? Log of x to the power of log 15. Are you happy? Yes? Okay. Okay. But then this log 15 can go to the back again. Yes or no?
Yes.
Okay. So you see, it becomes log 15 times log x. Yes or no?
Yeah.
So I did some gymnastics here. I jumped up and down. And I was able to say this is this. Yes?
Yeah.
But I jump up and down to reach to this. But I can go straight forward. Can you see why this is correct?
Yeah.
Yes?
You could factorize.
You can factorize. So factorization is a very straightforward way, yes? Because between two things, I can factor log x out. What is left here? Log 5. What is left here? Log 3. But what is log 5 plus log 3? Is log 15. Yes? So instead of writing this, I can simply write log 15 log x. Yes? And now, what do I have? I want to solve equations, so I have to isolate my x. The first step to isolate this x is to get rid of this log 15. By divide. So log x becomes this mess, log 3, log 5, log 225 base 3 divided by log 50. Yes? And then what is x? Again, the same trap. I'm sure that you will fall into it. What is x?
Same trap, right?
Yes, yes, you fall to the trap, and I enjoy the same thing every time. Yes. So why x? What is x? You see again. Why don't you answer this question? Log of x is 3. What is x? What is x?
Oh yeah, 10 to
10 to power 3. But now I told you, when I write 3, you can solve it. But when I write this big thing, you don't solve it.
that means 10
But
to
that
the
is
power.
exactly the same thing. Who cares? This is so ugly. If I ask you in the world of mathematics, what is this? A number. What is this? A number. So that is a little bit of magic. You fall into the same trap over and over again. Yet you need to come out from the trap, you know? According to Buddha, you fall into the circle of life over and over again. The purpose of life is not be able to reach to that level that you don't go back to the world again. so forget about the world. You are falling into this very simple trap over and over again in 30 minutes. Yes? Okay, so what can I, okay, tell me, what is the answer?
X equals to 10.
10 to the power of this mess. Yes? So to the power of log of 3 times log of 5 times log of 225 base 3 divided by log of 15. Okay, you might not be happy, but this is the solution. And be careful, this is extremely useful, because if you are an engineer or you are a physicist, except mathematicians cares about exact values, okay? But if you are one of those other fields you're working, you can put this in the computer and then you get the result as much as you want, okay? But if you are a mathematician, you have to have a fun with playing with numbers, okay? But this answer, you know what the answer should be. 25. Okay, so what can I do? I can design a question. I can give you an A-level question in the exam and I say prove this is 25. And then I don't allow you to use calculator. You already know the answer should be 25 because we solved the problem using a smile method, okay? And it was 25. And I am, hopefully, if I haven't done any mistakes in my way, and I got this answer, and this means this answer is also right, but this answer cannot be any number except 25, then otherwise I will be in trouble. Because I am going to the same problem in 2 different ways and I'm getting 2 different answers. If something like this happens, that is the end of the world of mathematics. Finish, goodbye. No one will study mathematics anymore. Because mathematics is very sensitive to inconsistency, internal inconsistencies. And that is an internal inconsistency. If this number is not 225, of course, if I haven't done any kind of stupid mistakes in the middle. So now you need to decide, have I done a stupid mistake, catch my mistake, or no, if you believe in me, you have to try to prove that this is really 25. Yes?
So, wait, you can begin by like rewriting that log 15 to times 1 divided by log 15.
This one.
Yeah, like rewrite that number, like that the exponent. Like rewrite it.
Okay, so let us now. This is another problem. So everyone happy with this one?
Yes.
Hopefully, I haven't done any mistakes. It means that I should be able, in principle, to show you that this number, a very weird number, is 25. So let us do it here. You see, this is the way mathematicians design problems, you know. Yeah. Every time they design a new problem, that is the somehow mental sickness sometimes, you know. When you want to go to bed, if you don't have any problem, you wake up, make a problem, and then you cannot solve it, and then you go to sleep, you cannot sleep. This is the way that you have this mentality, okay? So let us go back here. So, if you don't mind, you are right. You see, instead of writing everything to make myself in trouble, let me just concentrate on this, because if I know this, then I am done. Okay, so let me write this clearly in front of my eyes, you know. Okay, and then what? For example, let us consider this A-level question. So what is that? Logarithm of 50. For example, I give you this in the exam. There are similar questions like this in the book, but not that hard, okay? And then I ask you, okay, without calculator, find the exact value of this. Okay, and then you are allowed to do whatever you want to. So let me write it more clearly. Log of 15 is here. And I have put the multiplications that you can see. Okay, be creative, find a way. This is important. At the end, you should be independent of me. And it doesn't matter if you want to be a mathematician. If you learn these kind of tricks, thinking, you will be good in physics, you will be good in chemistry, you will be good in biology, you will be good in problem solving. Yes, okay. I want to hear from you. Yes?
Well, no, just instead of division, just make it multiplication, the entire thing, right? That's it, like
Which one? Be careful here.
you write it as 1 divided by log 15, like times 1 divided by log 15 up there. Like we move that up there.
This one up there?
Yeah, by
No, if I want to move it up there, be careful. So let us check, because this is important to understand. In principle, this means 1 over log of 15. Of course, instead of 1, I have this. But this is essentially this problem. So what you are saying?
Then we write times like that sequence.
Times that sequence, yes. This sequence is this.
And then change the log 15. Yeah, like,
Okay, tell me, what should I do?
right, log 10 to the base 15.
Yes. This is correct. So this is correct, but do you think it's useful?
Maybe since now you can.
Everyone agrees that what he's saying is correct?
Yes.
Because this invisible, so thank you for the word, by the way. Invisible is very good. This is an invisible base. So it is an invisible base, so it is 10. So when I switch it, 10 goes up there. It becomes visible. Yes? Okay, so now, but I don't think any idea. I don't know. If you can just help me to do it yourself. Your idea is not wrong, but is it useful? You have to defend it yourself.
No, I thought wrong.
Okay, so let us clean. No worries, you know. This is very natural. I want you to feel the process. Okay, then what?
Wait, maybe like you know if it was.
But you know something from experience. It is still on the board. Why don't you want to do something with this big number, which is an obstacle in front of you? Yes, why don't you do that now? Because now you have some information. I mean, if I were you, I would start with this big bad part. Because to be honest, this is not an obstacle in front of me. These are what they are. Yes? Logarithm of 3 cannot be simplified more. Logarithm of 5 the same, logarithm of 15 the same. But logarithm of 225 to the base 3 can be simplified a little bit more, yes? So how? Let us decide. You see, this is a strategy planning. I am planning a new strategy within another strategy, yes? So now my strategy is to see, I ask myself, Baba, can you say something about this, which is more useful? Yes, you can. you just told me what is 225? 15 to power 2, okay? So let us do that. Yes? Is it useful? Yes. Why? Because 225 is switched with 15. Which one is better for you to work with? 15. But then there is a 2 here. But that 2 is not an obstacle. You know it. What can I do? No, why should I split? I move it there. We can do that, but why we should do that again? Yes? Yes or no? Okay, then what can I do? Can I do something with this one as well? For example, 15 is what? 5 times 3. Or, no, let us keep it like this. Okay. Now here, because I am a little bit more experienced, I say, okay, the problem is solved. Why? Because I go backwards here. This logarithm of 3, logarithm of 5, just copy and paste. What can I write for this one? It's in front of me, 2. But why should I put 2 here? I put it here. It's always good to be organized. Of course, I can put 2 in the middle, but 2 is here is more beautiful. And then I have logarithm of 15 to the base 3. And then I have logarithm of 15. Okay. Yes? And then I say that, okay, I am so unlucky because if it was not 3, if 3 was not there, then what can I do between these two? Cancel. Yes? But unfortunately, it is there. This is the way you need to think. But then, how can you solve the problem? Yes, it is there. But what do you know? What can I do? So let me just, I want to wait for you. So I copy and paste the ones that I am not changing. I am waiting for you to tell me what to write here, which is not only true, but useful. Copy and paste, copy and paste, copy and paste, copy and paste. What can I write for this one here? You know it, I'm sure. You used it several times.
Division.
What do you mean by the, yes. So what should I write?
Log 15 divided by log 3.
Log 15 divided by log 3. Yes? First of all, is it true or false?
True.
Yes. Is it useful or not?
Useful.
At least it is useful for this one and that one are gone. Yes? And then what is left? 2 log of 5, log of 5, log of 15 divided by?
You can then take away 2.
Then this one is also gone. It becomes 2 of log of 5. And then these 2 can go up there. Yes or no? But I hope that you have your, so am I in trouble? No, because this number that I calculate is not the whole expression. Is what? The exponent. So x is what? X is 10 to the power of this, which I calculated now. So it is 10 to the power of log of 25. What's the answer?
25.
It's 25. Why? Because of this invisible base. Yes? This invisible base and this base are gone. That's 25. So that's enough. So I want you to, I don't think there is a person who doesn't like these things. It's interesting, everyone is sitting and solving puzzles and problems. If you see a movie which is mysterious, you like it. And that's the same thing, So, but might be because you cannot cope with the problem, hard problem, you say that, okay, I am bored, so I don't like it. But little by little, you learn thinking, and that is important. I'm trying to teach how to think, which is, of course, comes with practice. Any questions here? Are you ready for another problem, challenging one?
Härifrån man kan få 25. Eftersom det finns 10 in the base.
Vad är du ser det här?
Där har jag förkortat bara den här. Eller inte för att förkorta, men ja. Är det här numret? Det är it is 10 in the base. I did.
Okay, so let me write another problem here. So see how many of you can solve this problem. Don't worry about the exam. None of these type of questions will be in the exam. Okay? And studying for exam is something really bad. The goal should be learning. And of course, if you learn, grades and points will come automatically. And then I am not stupid to give some of these kind of questions in the exam, unless you really want to have a challenge in a separate, different exam. Okay, so now let me write this equation. I think there are good ideas there in this problem. So again, we want to find x. 1 plus logarithm to the base 5 of logarithm to the base 32 of another logarithm to the base 2, and then x, yes, and then is equal to logarithm of 2 to the base 5. Okay, before you start, to make sure that you are not confused with these successive logarithms, let me give you another example here. Can you tell me, if I write, for example, logarithm of 2, 16, and then I write logarithm of 4. If I ask you, this is by the way at the level of your course. If I ask you find the exact value of this, can you do that? So
16 to the power of.
Yes, you ask about this number first. You know, because every logarithm should have a number in front of it and a base. So this is a logarithm whose base is 4 and the number in front of it is this number, which in turn is another logarithm. Yes? So if I ask you what is this number, you should be able to answer this immediately at this level now, because we're solving extremely hard problems. This should be nothing for you. What is that for? Why? Because logarithm of 16 to the base 4 to the base 2 is asking me which number is that, so that 2 to that power is 16. So what that number is? 4. So this is a fancy way of writing 4. So this is logarithm 4, but this one is also 4. But logarithm 4 to the base 4 is 1. So you understand what is the meaning of consecutive logarithms, successive logarithms, yes? Okay, but this is a little bit harder because I'm not calculating. I'm going to find x for which this works. Okay, so I want to wait for you because I want to hear from you. First of all, think about it individually, come up with some ideas, and then try to sell it to me to see if you can convince me to buy it.
You know the thing inside the parentheses?
Mm-hmm.
Can you read the inside the parentheses? Yeah. Can you rewrite that as like 32 to the power of log x to the base 2?
Okay, so let me, because that's not easy to answer immediately. What should I write? Only for this one?
Yeah. I'm like, can you write that as like 32?
Yes.
To the power of log x to the base 2.
No. You see, I told you, when you see log 32, imagine that this is your box. This combination is this.
Yeah.
Yes?
Yeah.
Okay. Of course, these are hard problems. I shouldn't expect you to be able to answer immediately. It shouldn't take that much time, but let me ask you, what do you want? Because you know that if of course you need to have it is in your memory. You know that there is no formula that helped me to cope with this one, because these are consecutive logs. If you just review a little bit about in your memory or in the formula sheet, you don't have any formula related to log of a log of a log or something like that. So instead of thinking to do something here, forget about it, because it is probably not going to work. This was an exception because I can start, because that number was given, so I started doing it step by step and it was finished. But unfortunately, x is not given. So I cannot start doing this step by step. So give up this idea, I want to do something here immediately. Because what do you want to do? Oh yes, you want to solve it, but there is nothing very concrete that I can do right away here, because when I see my toolbox, my formula sheet, my memory, I don't see any formula for log after one after the other. Mm.
Move the one to the other side and rewrite it as log 5 to the base 5.
Very good. I will do that. I like this idea. But before doing that, which one is horrifying? This middle term is a very ugly one. But I told you, you are a human. This is just my handwriting. You shouldn't be scared of what I write on the board. It is not alive, you know. So it means that you are more powerful. You need to think, is it distracting or not? You see, you can imagine this is your box. But this is oversimplification. Because what do you have now? You have 1 plus box is equal to logarithm. By the way, it's not that oversimplification. You see, everyone look here. This idea of box is very important. Don't let horrible things distract you. You see, if I give you this, do you agree where is your unknown hidden?
Box.
In the box. And if you want to find box, is it hard for you? Now everyone tell me in a matter of 1 second, if you want to solve for box, what do you do? As Omar said. So this is why, this is why I say that you shouldn't spend so much time to understand to move one to the other side. Please listen to me, because that's a very important idea. My unknown is hidden here. So consider this as your box, don't look inside. Still, you know that what is inside is hidden. But the structure becomes so simple that you know what to do. If I ask you find the question mark, what do? You really move on to the other side. Again, listen to me what I'm saying and use it over and over again. So everyone agrees that this is a good idea to move one? Yes? Okay, so let us do that. So what happens? The box will be left on this side, because I know that if you listen to me, you can catch it in 1 second. If you don't listen to me, it doesn't matter how many number of problems I solve for you. Yes? Okay. Okay, now you have a little bit of experience. As Omar said, what is good name for 1 in this context? Log 5 to the base 5. Yes? I can write it log 7 to base 7. Why did I choose this one? Because the bases are the same. So now if you do that, can you tell me what can I write for this? What? It's a difference of logs with the same base. So it becomes log to the same base of 2 over 5. Okay, it's good. But now I want to wait for you. The people who didn't listen to me, they get stuck again. The people who listened to me, what?
Division.
No, this division we did.
I mean, you can divide that number on both sides.
No, but what is the point? Don't. Yes, we can, but it is not helping, because I want to isolate x. You are dividing by this, you are also putting this below this one. So you are not isolating it. You are making it more complicated. You are making it have more kids, you know. Yes?
Is it possible to divide log 5?
No. Be careful. Don't. This is, I want you to answer it yourself. Be your teacher. I mean, so don't ask these questions. You see, if I say you are asking me what, divide by log 5. Log 5 doesn't have any identities. Log 5 is not something. Can I ask you calculate log base 5? Do you give me an answer? No. Log 5 is not a number unless I put something in front of it. So I cannot divide by something without identity, yes.
If you divide that number on both sides, you see that they have the same base,
Mhm.
and so you can replace 2.5 with 5.
With 5. You can do that, yes, but don't make it complicated. Okay? I want you to see what is happening. Again, the idea of box. If I make this a box, this is oversimplification. Box is this one. Okay, there's no point. So what can I say consider as a box now? I consider this one as a box. And then look, logarithm of 5 box is equal to what? Logarithm of 5 to 5. Can you tell me what is box immediately? What is box?
2 divided by 5.
Yes? So you can, again, you see the same trap, so I'm enjoying too much. Yeah, try to come up from this circle. Why you could answer this question immediately when I wrote it in that way, you told me immediately box is 2 over 5. But when you see it in this strange way, for some reason, you don't say the same thing. If I can fix this in your brain somehow, I cannot fix it. My duty, my role is to draw your attention to this over and over again. At some point, you need to learn it yourself. Okay? Okay, so now I go one step further. Can you tell me what is the box now? Everyone with me? Yeah, decide not to fall into another trap. There is another trap coming. Be ready, okay? So what happens? Do you agree? I put this in my head to be box, and I compare it with that one. My problem is so simple. I immediately can see my box is 2 over 5. But this is my box. Logarithm 32 logarithm x2 is equal to 2 over 5. Everyone agrees? You see, you told me yourself that box is 2 over 5. But what is box? Box is this guy. I copied and pasted there, and then I copied and pasted 2 over 5 there. Yes or no?
Yes.
Okay. Then what? Ready for another trap?
You can try to change 2 over 5 to a logarithm with 32. With the
You
change
see,
base.
don't fall into the same trap.
Yeah.
You might be able to solve it, and I'm sure that if you sit down, you will solve it. But I want to also learn what I'm telling you. Yes? Yes, I'm not saying that you will not be able to solve it. But I want you to learn this one, because if you learn this one and we leave today, and I will happy that I told you something and you learn. Yes? Yes? So, yes.
32 to the power of 2 divided by 5 is equal to log.
Yes. But again, the same story, you know, because this now can play the role of my box now. Again, can you solve this problem? If no, I don't know what we are doing then. Can you answer what box is? No, no.
32 over 2 over 5.
No, this is, so, again, what is box? Everyone, what is box? What is box?
32 to the power of 2.
Okay, so what is box?
32 to the power of 2 divided.
But do you agree there is a gap between this one and this one in your brain? I don't know how to fix it.
Literally, I think they put it down.
Yes? So everyone tells me box is 31 to the power 32 to the power 2. But instead of 2, I put 2 over 5. You change your strategy, you change your mentality. This I don't understand. Yes? So what is the box here? What is the box, everyone? What is the box?
32 to the power.
Yes, the box, which is this guy, is 32 to the power of 2 divided by 5. Yes? Everyone, what is x now?
2 to the power of.
2 to this power.
Yes.
Yes? Because if I tell you what is log of x to the base 2 is 7, what is x? You tell me x is 2 to the power of 7. But instead of 7, which in the world of mathematics is just a number, is being played by this strange number. But that's a number. So x becomes 2 to this power. We are done. Are you happy?
No.
Yes. It is correct. So if there are 4 points, you have 3 points here. But ugliness is something mathematicians cannot tolerate that much. Okay? So you have to get rid of ugliness. Okay, so it is completely correct. And I want you to understand that the idea of a box is extremely important. So you little by little make the problem simple and simple until you could solve it. But now, let me ask you, this is Math 1C now, a hard problem in Math 1C. Can you simplify that number without calculator? Do you have it in your memory? 32 is related to the power of?
2 multiplied by 2 multiplied by 2.
How many times?
6, 5 times.
5 times. Yes? So 32 is 2 to the power of 5. Yes? So if I ask you 32 to the power of 2/5 is what? Instead of this one, what do you write? And then to the power of 2/5. Everyone, what's the answer?
2 to the power of 2.
Yes. Why? Because these two should be multiplied. It becomes 2 to power 2. And what is this 2 to power 2? It's just 4. So this number that you see up there is what? 4. So the answer is 2 to power 4. But what is 2 to power 4? 16. Yes. So that's the solution to this problem. Very beautiful problem. Are you ready for another?
Yes. Bring it on.
Okay, let me ask you something. I want you to see how much. I want to give you a system of logarithms. A system involving logarithms. You see, the world of mathematics is full of creativity and combination. When you learn something, you can combine them. So let me ask you this. I want you to solve the following system. I want to see how many of you can solve the system. To be honest, I really don't talk because it is very hard for me to don't talk. But anyway, I will not talk, I will promise. Okay, so logarithm of x to power 2 y cubed is equal to 2. And then I have logarithm of logarithm of x over y is equal to 1. It is what is called in mathematics, this one. When you see this, it is called a system of two equations. In how many unknowns? Two unknowns. But this is not one of those standard ones because the logarithm is involved. Okay, my question is to find x and y. And I want to wait for you. I have the answers here. If you tell me, I can check it with the answers in the book. What is x, what is y? No, just tell me. It might be that's correct. No, what is x then? What? That's correct. Thank you.
Is y 0.2?
No, y is 1.
1.
And then I told you that this is not a hard problem that much. I don't know. I want to hear from you. For example, what do you think it is a good thing to do? It's a logarithmic system. But logarithm is just a mask. You can immediately get rid of log. Yes? For example, can you tell me I have log of something equals to 1? What is that something? No. Log, the base is 10. Can you tell me the box? 10. Okay. So again, the box idea, the same trap. So this is your box now. So log of box is 1. So what is box? 10. Yes? So this is 10. Yes or no? Again, the same trap, you see? Get rid of this log. The box is this one now. What is the box now? I don't understand why you wait. Log of box is 2. What is the box? 100. So is it a logarithmic system? No. So logarithm has nothing to do that much, just the only this one. Okay, but now again, I want to test your understanding. This is not a standard system. In a standard systems, we have two methods. What are the names? You have the exam next week. What are the names? Method of substitution or method of addition. But method of addition was not useful unless you have very particular case of equations, linear systems. Is it a linear system? No. So method of substitution is only one that works. What is the gist? What is the soul of method of substitution? What does it mean? Not isolate. Eliminate one of them in favor of the other one. How many unknowns you have? 2. You cannot solve 2 unknowns. You can solve only one unknown with one equation. So it means the method of substitution, this is why I call this name better, elimination. You eliminate one of them and then you choose the simple one. For me, this one is simpler. I multiply everything by y. So x becomes 10y. Then I go here, instead of x, I put 10y. So what happens? It becomes 10y to the power of 2. Y cubed is 100. Yes or no? You see, the reason that you don't do things fast and you do a lot of noisy things, because you don't listen to my important points. You see, we had a lot of things. I'm not expecting you to memorize everything, to have it in your head, but I expect you to remember the general way to tackle a system, which is method of elimination. And method of elimination means to get rid of one of the variables in favor of the other one. If you just remember this, then I am sure that you will choose this one, not that one, because you yourself immediately, this is easier. And then if you remember, I want to get rid of fractions, you just multiply by y. And then you go back to this equation, you remove x and put that expression. Is this an equation? Yes. How many unknowns you see? So in principle, you can solve. So it is also important. There are not indefinitely amount of time. Even in national exam, you have 5 hours, but 5 hours for 29 questions. So you have to be able to do things fast as well. Okay? So here, what happens here? Now, how many of you can immediately solve this equation for me?
Y is equal to 1.
Yes. Why? Because this is 10y to power 2, which is 100y squared. There is another y cubed here, is equal to 100. What do you do first? I get rid of 100. And this is y to the power of 5 is 1. So what is y? 1. But when y is 1, I want to find x as well. So which one I do? X is here, is crying out. Okay, I'm here. 10 times y. Y is 1, so x is 10. You see? I want to change your perspective about hard and simple problems in math. Of course, if you don't remember these things that I told you during the teaching, you consider this hard. You consider every problem I give you hard. But if you remember little things, not a lot of things. In my education system, I remember a lot of things in my head. I don't expect you to do that. But I expect you to remember the important points. For example, if someone asks you, because you know that, by the way, one thing I liked about the national exam, they have, this is now obsolete, they have oral exam. Yes, that is very good, you know. For example, oral exam is good. For example, I bring you here, I ask you, okay, Hasbullah, tell me about systems. What do you know about system of equations? It's very good, because now you start, first of all, you start, you need to start turning on your engine, okay? And then suddenly you say, if you cannot refer to elimination, for example, I can ask you, what is the important method to solve any system? I expect you to tell me substitution. And then I ask you, okay, can you describe a little bit what is the method of substitution? If you cannot express it in words, then you have difficulties. How many of you saw the video that I uploaded during the post? Yes, that is Jordan Peterson is talking about how to remember things. Yes, try to look at that video, it's 7 minutes. And that person is not Jordan Peterson. The idea is from Jordan Peterson. The person who made the video made it very graphical and very nice to understand. Okay, So this is why you have to express it to yourself. Otherwise, you will forget. This is important. Yes, if you want, I'm sure if you like mathematics, if you want to be a good problem solver, you have to respect these things. Okay, I want to write a very challenging system here. That is up to you. If you like, work at home. Okay, this is the system. Logarithm of x to the base y plus logarithm of y to the base x is equal to. This is a challenging one. This was not challenging. 2. And then x squared plus y is equal to 12. Yes, I'm not forcing you to think about, but if you are interested, go home, and when you are relaxed, come back and solve this problem. If you really can solve this problem, you are really on the safe side, understanding, logarithms, systems, a lot of things, you know. This is why hard problems are good. Because if you solve a simple problem, in one simple problem, you have one idea. Finished. But solving a hard problem, you should be able to combine a lot of ideas in one single problem. That is exactly when you learn how to do these ideas, problems. Okay? So, if you like it, think about it at home. On Friday, I will work on exam, okay? Friday, I will review what is coming to exam. On Monday, the same. And then on Tuesday, we will hopefully have a very good exam. Please study, okay? But think about this if you like. Any questions? Thank you.